Can you able to see the slides?
Yes, ma'am.
So today is your last practical class. So today also you are going to study two practicals, right? So do you have any doubts in the previous practicals? So last class you studied about this determination of soil texture by field method, right? So today this class you are going to study the determination of soil texture by Pipette method. Okay. So can you tell what is soil texture? Okay. That's a simple definition. Relative proportion of sand, salt, and clay. Okay, so what are the methods we can use to determine the texture? You already studied one. Sorry, I couldn't hear you. What are the methods? Any one of you?
Hydrometer.
I couldn't hear you. Sorry. Can you please say it loudly?
Field method.
Okay.
Pipette method.
Okay. So these are the main two methods we are using. Okay. Another method is also there. That is hydrometer method. So in this semester we are not going to study that one. Okay. So can you tell one advantage of this field method? Advantage and disadvantage. These things we discussed in last class. Please, you can share your answers. I'm just asking.
Excuse me, ma'am. We can't hear you clearly.
Oh, can you hear me?
Yes, ma'am.
Okay, sorry, there's a problem with in our network. In Kirnaji, there's heavy rainfall. Now my voice is clear?
Yes, ma'am.
Okay. So can you tell me what is the advantage and disadvantage of field method? Yes?
Not accurate.
Okay, so that one disadvantage. Not accurate. So this can be vary with persons. So there may be so much of errors. Okay. The advantage is what? You can simply what? Okay. Yeah, no need any equipments and other things.
Easy.
Yeah, easy method, very simple method, right? Okay, for this pipette method, we want a laboratory setup. Okay, and we can measure the percentage of sand and clay. Okay, so this method is very accurate than the field method. Right? Okay, so we are going to use a sedimentation jar to sediment all these uh, sand, silt, and clay. Okay, so let's see the principle of this practice, right? So here we are going to sediment the particles, okay, based on Stokes law. Here you can see the equation. So that is the Stokes law. Okay, V is equal to H by T. Okay, here V is equal to, V means terminal velocity of settling particles. Okay, so you all know what is velocity, right? So what is velocity? You can just see an answer. Velocity. Here the velocity is equal to h by t, that is the traveling depth over time. Okay.
Okay, ma'am.
Okay. So this is the standard law, Stokes law. Okay, stated by Stokes. You can see the equation. Mm, h by t is equal to 2g within the bracket d1 minus d2 multiplied by r squared over 9 meter. Okay, so d1 is the particle density of the soil and d2 is density of dispersion medium. Okay, and g, you already know that gravitational acceleration, and the meter is viscosity of the medium. Okay, so uh, with the using this equation, we are going to determine the texture. Okay, so we are going to check the sedimentation time, right? So using the sedimentation time, we can determine the proportion of sand, silt, and clay. Okay, did you understand?
Yes, ma'am.
So if there are any problem with my sound, please let me know, right? Okay. So you all know about this diameter of this sand, silt, and clay, right? You study all these things in your theory. And here you can see the settling time. Okay, so different type of soil may settle in different time. Okay, for sandy soil, it takes around 0.025 seconds to settle down. Right? So using this settling time, we are going to determine how much of sand or silt or clay present in the particular soil. Okay, so using this settling time, we are going to determine the texture. Right? So you can note it down this settling time in your record books. Okay, so here they gave some data related to the Stokes law. Okay, so density of the medium and density, the dispersion medium, gravitational acceleration, and viscosity of the medium. Okay, so no need all these things, just you have to remember this settling time. Okay, so settling of time is very short for the sandy soil, right? And it takes around 6 hours or 7 hours for settle down of clay particles. right? So these things you have to remember. Okay. And sure, these things I already told. Okay, so silt and clay are determined based on their settling time. So okay, after the removal of silt and clay, you can find the fine sand fraction. Okay, so for that you have to take some soil sample after the sedimentation, and you have to place it on the oven, and you have to take the oven dry weight. You all know how to take the oven dry weight. Okay, so with one equation we can determine the percentage of each and every particles. Right, so we will see that calculation part later. Okay, so when we are using this Stokes law, there are some assumptions. Okay, so we have to take some assumption while using the Stokes law. So do you know anything about these assumptions? Viscosity, that means the dispersion media viscosity is less. Yeah, that one also correct, but I'm asking that basic assumption. Okay, constant temperature, very good. Then any other things? So why we need to maintain a constant temperature? And just with temperature, right? Yeah, yeah, good. So any assumptions? Any other assumptions? You can see the slide and tell me. Yeah, no any Brownian motion. Absolutely correct. Okay. Then any other answers? Any other answers? I think this equation you studied in your A level. Okay. So here they mention the particle should be spherical. Okay, and the particle must be large enough to avoid the Brownian movement. Okay, and we should maintain the temperature also. If the temperature is changed, the viscosity of the dispersion media will change. Okay, so we have to maintain the temperature also. And we can assume there is no any slip between the solid particle and the water. Okay, so these are some assumptions while using Stokes law. So you have to remember these assumptions also. Okay, during the exam time, they can ask the principal that equation and these assumptions. Right, so try to remember all these things. Okay. So then let's we move into the procedure part. Okay, so for that we are going to use hydrogen peroxide. Okay, the first step we are going to treat with hydrogen peroxide. Okay, so do you have any idea? So why we want to use hydrogen peroxide? Sorry, remove that. Unwanted particles means what? We are closer to the answer, but unwanted particles means. Okay, organic matters. Okay, so we are going to oxidize this organic matter by adding the hydrogen peroxide. Okay, for that we have to add around 50 or 60 milliliter of hydrogen peroxide to the soil. Okay. Okay, for that you have to take around 20 gram of soil. You all know you have to sieve the soil in 2 millimeter sieve, and then after you have to add around 50 to 60 milliliter of 6% of hydrogen peroxide. Okay, so for the digestion purpose, you have to keep that set up in hot plate. Okay, so you have to decompose that organic matter and you have to keep some time that setup to convert that organic matter into oxidized form. Right, so this is the first treatment. First, we have to remove the organic matter. Okay, so that is present in the soil. You have to remove the organic matter that is present in the soil. Right, for that you have to add 6% of hydrogen peroxide. Okay, so are you clear about this procedure? Please note down, right? So what is the purpose of adding hydrogen peroxide? Okay, okay. So then let's move into the second step. Okay. So can anyone read the slide? I'm just asking you to read.
Ma'am, can I read it?
Yeah.
A treatment with acid and filtration. Add 20 milliliter of 2NHCl and shake to destroy CaCO 3% in the soil. Allow the contents to react for about an hour with intermittent shaking. Filter the contents through a Buchner funnel under vacuum. Wash the soil with distilled water until the filtrate runs free of chloride.
Okay, so here we are going to use acid to destroy the carbonate. Okay, in first step we remove the organic matter, and in the second step we are trying to remove the carbonate that is present in the soil. Right. So for that you have to add around 25 milliliter of 2NHCl to the soil, and then you have to uh, shake that solution intermittently, and then you have to filter that solution. Okay, I hope you all know that Buchner funnel. In coming slides, I will show the Buchner funnel. Okay, I hope in laboratory techniques you saw that one. Okay, so using a vacuum setup, we can remove all the chlorides. Okay, for that we have to add some amount of water, distilled water, and using the vacuum we can remove the chlorides that is present in the soil. Okay, so this treatment that is used to remove the calcium carbonate and the chloride. Okay, so are you all clear about this step? If we ask what is the purpose of adding HCl, you have to say, okay, so to remove the calcium carbonate. So did you understand this one?
Yes, ma'am.
So then let's move into the next step. Okay, so this is the actual procedure we are going to use to determine the percentage, right? Sand salt percentage. Okay, so to this one, we are going to use sodium hexametaphosphate. Okay, so we can call it as Calvin. Okay, so this is an dispersion agent. Okay, so using this one, we can disperse the sample. Right? You have to remember this name, sodium hexametaphosphate. So the chemical name also you have to remember. Right? So you have to add around 10 milliliter of sodium hexametaphosphate and you have to add distilled water. Okay, so in this picture you can see. So this is the sedimentation jar. I will show that setup. Okay, you can see. So it is also like similar to the measuring cylinder. We can call it as sedimentation jar. Okay, so within that we are going to take the soil and we are adding all these chemicals. Right, so after removing all the organic matter, calcium carbonate, then we have to transfer the soil into this jar and we are going to add the calcium. Right, so within this jar we are going to add the calcium. Okay, so carefully observe this one because sometimes it will come to your spot examination. Okay, so I think this volume is around 1 liter. So there is a cap also present in this setup. You can close the lid by this cap. Okay, so this one we can call it as sedimentation jar. Okay. Okay. So then you have to use this 0.2 millimeter sieve to sieve the soil. First you have to add the galgan, then you have to use one sieve. You can see in this picture. I think the picture is not clear, but you can observe the second picture here. Okay, so you have to use this 0.2 millimeter sieve and you have to transfer some amount of soil through this sieve. Okay, so what is the size of sand and silt particles? Sand. Okay, then silt. Okay, okay, good. Okay, So after adding the soil, you have to again wash with water. Okay. So you can use distilled water through the sieve until no more clay and silt remain on the sieve. Okay, so you have to add more and more amount of water. Right, so you have here you are going to use 0.2 millimeter sieve. Right, so we couldn't make a video this time, so that's why we are showing some pictures to you. Right, okay. I think it's difficult to understand the procedure with the pictures, but anyhow, please try to understand the procedure, right? Okay. Okay, so then you have to transfer the coarse particles that is retained on the seed to the crucible, and then you can take the oven dry paint. Okay, so you have to take the sample so that is retained in the seed. Okay, and you have to keep that sample in the oven and you have to take the oven dry paint. Right. Okay, so then the procedure for separation of silt and clay. So you already take a 1 liter jar, okay, 1 liter sedimentation jar. Okay, so I think you add already 10 milliliter of sodium hexametaphosphate and you use 0.2 millimeter sieve to pass that some amount of soil and you add uh, water. Okay, so then for the separation of silt and clay, you have to add more amount of water, right, to homogenize the suspension. Okay, and you have to observe the sedimentation. Okay, so here they mention about the temperature. Okay, so I already told to use that Stokes law, we have to maintain a constant temperature. Okay, so that's why they have mentioned the temperature control chamber. We have to keep the jar into the temperature control chamber. Okay, so no need to worry about that procedure. Just we have to maintain the temperature throughout all these procedures. Okay, so after adding a more amount of water, you have to stir the solution. Okay, you have to stir the solution. You can use the hand or you can use the rod to stir the solution. Then you have to close the lid and you can invert the jar. Okay, so to mix the solution, so water with that soil sample, you have to do like that. First you have to stir, then you have to invert the sedimentation jar. Okay, so before inverting, you have to close the jar with the lid. Right? And you have to allow some time for the sedimentation. Right? So did you understand this procedure?
Yes.
Okay. So we are giving time for the sedimentation. So can you tell the time, settling time for silt? Okay. one of you asked about the temperature part. Here I already mentioned the, the dispersion agent, that is the viscosity of the dispersion agent will change with the temperature. Okay, so to maintain the viscosity, we have to maintain the temperature. Right? That's why we have to maintain a constant temperature throughout all these procedures. Okay. Now, did you understand? Okay. So, can you tell the settling time for the silk? Yeah, very good. 4 minutes and 10 seconds. Okay, so after 4 minutes and 10 seconds, you can observe the silt will sediment. Okay, so with the time factor, we are going to determine the texture. Right, settling time. Okay, so can you tell the settling time for clay?
6 hours and 56 minutes.
Okay, very good. So it takes more amount of time to sediment. Right? Clay takes more time. Compared to the sand, clay takes, I think, very long period of time to precipitate in the solution, right? Okay. So after this procedure, you have to pipette out 25 milliliter of sample. Okay, I will tell what is the purpose of doing like this. Okay. Okay, we will move to next procedure. Okay, so this procedure for separation of silt and clay. Then we will see for the separation of clay. Okay, for separation of clay, it will take around 6 or 7 hours, right? So this method is a time taking for practical, right? Time taking experiment. So we can't conduct the experiment for so many samples. So that is one of the disadvantages of this method. Okay, so by field method we can analyze the texture for so many samples, but for the time consuming purpose we can't conduct this experiment for so many samples. Okay, so you have to remember that point. Okay, so we can't conduct this experiment for so many samples. Okay, so that is one of the demerits of this experiment. Okay. Now let's see the procedure for separation of clay. Okay. So you already add more amount of water and you already stir the solution. Okay, so you have to again stir the contents. Okay, for 1 minute you have to again stir it continuously. Okay, and then after that you have to keep it out around 25 milliliters of sample. For this you have to take that 25 milliliters of sample at the depth of 10 centimeters. Right? So before you can already took the sample here for the separation of silt and clay also you have to take 25 milliliter of sample. Here to determine this separation of clay you have to take 25 milliliter of sample at the depth of 10 centimeter. Okay, so this sample you have to take after 6 hours and 56 minutes. Okay, earlier you took the sample after 4 minutes and 10 seconds. Then after you have to allow 6 hours and 56 minutes. Only then after you have to take 25 milliliter of sample. Okay. Did you understand that one?
Yes, ma'am.
Okay. So because we are considering the settling time. So that's why we are taking the sample in different period of time. Okay. So then you have to transfer that pipette powder solution to the moisture can or to the dish, and you have to dry that one. And you can get the oven dry way. Okay. Okay. So after this, you all, I think you all got an idea about the procedure, right? Do you have any doubts? Okay. So then let's see, look into the separation of fine sand. Okay. Previously we saw the procedure for separation of surge and clay. Then let's look into the separation of clay. And now let's see the separation of fine sand. Okay. For that you have to further turbid suspension to the 500 milliliter of beaker. Okay, so after getting the 25 milliliter sample, you have to transfer the suspension into 500 milliliter beaker. Okay, so from that you can take another sample. You can observe that turbid suspension in this picture. Okay.
ಅಂಗರಂಚಿ ಅಂಗ ಸರಿ ಇಲ್ಲ Yes, ma'am.
Okay, so for this also you have to take the sample and you have to transfer the sample into the moisture can or the crucible, and you have to get the sample in the oven, and you have to get the oven dry. Okay, so while see the readings, you will get an idea. Okay, let me move to next slide. Okay, so these are the equipments and instruments you have to use for this practical, right? So first picture you can see the oven, and second one is the can, and weighing balance also you want to use to weigh the samples, right? Then here you can see the sedimentation jar. Okay, for this there is a lid. Lid also we can use to cover the sedimentation jar. Okay, so here you can observe the vacuum setup. Okay, so what is the purpose of this vacuum setup? Why we are using that vacuum setup? You can see and tell the answer.
Treatment with acetone filtration.
Sorry, treatment.
remove the chlorides and
Okay, so to remove the chlorides, we are using excess amount of water, and then after we have to use that vacuum setup to remove the chlorides. Okay, so please carefully observe that setup also. Okay, so this is the vacuum setup. Okay, so then this one is crucible. So you can transfer that pipette outed solution to this. Okay, or to the moisture can, you can take the weight. Okay, so then these things you already know, pipette, sucker and sieve, all these things, right? Okay, so here I gave all the readings.